Hi gang, I'm back to keep rolling while I'm on a roll with these things. I guess I have a lot of pent up energy here and inspiration from being gone for a year. And lots going on here. So let's get to it by shrinking me down here to tiny size and getting out of the way. Now, today's thing is called repulsive gravity. And that's a bit of a misnomer, maybe, kind of, but that's fine. I'll take it, because it works in our favor anyway. So, now that I'm tiny and have my glasses on, let's start reading here. Here is the thumbnail. And yeah, this is an extension from a video by Jesse Michaels with Eric Davis and Eric Weinstein, heretofore known as the Erics. And, if you recall, they were saying, gee, I don't know, General Relativity has nothing to work with. And I can see why they would say that. Even people at that level might not have noticed this, because it's not from the high-level equations, but it's from the equations that build up to the high level. So you had to dig down into it to find this, and it's in there. So that's what we're here to talk about, and basically to make a point like, here it is, it's right in there, and it's called repulsive gravity for a reason. We'll get into that. But it's also called colloquially, and in quotes, by the guy that really came up with this, found the equation that really shows it, and he calls it anti-gravity. So whatever, you want to argue about it, that's fine. He calls it that, that's what it's so called. But we'll get into that later. But I'm just going to read this here. And I'm going to try to get to the point very quickly, and then get into all the talking and setting things up and teases. We do that in reverse. The point is, if you run these light beams, in other words, photons, side by side, and they're going the same way, and they're close enough, a thing called repulsive gravity happens as between the photons. And but it's not pushing any mass or anything like that. All that means is the gravity in the middle there, between the beams, between the photons, is canceled out. Each side cancels out what the other side is doing. And the net effect is there's no gravity in between those beams or photons. Now I imagine the effect, it's perfect if you're one graviton away. But, is that realistic? I don't think so. So you get them as close as possible. And, you get them as close as possible. Easy enough. Easy concept, right? And even if they spread out, if they're coherent and they're all going the right way, they're going to have some effect on gravity. Not as strong as it is at its strongest, which is what these papers are about, basically. But it is still there. So I'm just going to read this part. This is going to be a lot of technical stuff for the truly interested. So that's why I got that stuff, got the key point out of the way first. If you want an area that not only is like a vacuum chamber, which is very light, of course, light in weight, because there's nothing in there but photons, wait till you get your photons organized in there and going in those straight lines. Because what will happen then is the gravity in there will cancel out. It'll be nothing. So you have something that is a vacuum, only it's an organized vacuum. It's a deterministic one that we are making. You're not going to find it in nature, probably. But you can make it, and it's a thing that is light, where gravity has no meaning in there, because it's canceled out by the repulsive gravity action as between the photons. So imagine if you're sitting on a ship that has that in it. How do you like that? Does that work for you? Eric's? Anyone else? I think that's a way that's a path to pursue. And unlike a lot of this other stuff, it's right there in General Relativity, that's the thing that happened to me last week as I found the fine print. It is in there. I knew it had to be in there, but I saw it this clearly and found it. Well, now I found it. I'm bringing it out here, and there it is. So let's go. So who brought up the word anti-gravity, grok? Quote, it was Gaetano Vilasi, one of the three co-authors. In the key paper, The Gravity of Light, etc., and so forth, the authors repeatedly refer to the phenomenon as, quote, repulsive gravity or anti-gravity, as it was usually called. In other words, it's a colloquial term. Okay, translated from Italian, too, by the way. They open the discussion of the topic with this exact phrasing. How's that for getting to the point? While reviewing the historical interest and repulsive effect of gravity. And we'll go over the history of it. And it'll have names that you've heard of before. The paper frames their own work on light sourcing spin one-like graviton waves as providing the pure general relativistic mechanism for such repulsive anti-gravity-like behavior without needing exotic matter or modifications to GR. Did you hear that out there, everybody? Without needing exotic matter or modifications to GR, or any of those other fairy tales that are out there, getting clicks. The same language, quote, repulsive gravity or anti-gravity, as it was usually called, unquote, also appears in closely related works by the Vilasi group, such as, quote, repulsive gravity of light beams, papers and papers and papers. So while all three authors contributed, Gaetano Vilasi is one of the most directly associated with using and contextualizing the term, quote, anti-gravity in these papers. He's frequently the corresponding author or lead in the group's related publications on the topic. In short, the group as a whole uses the word, but is prominently featured in the writings led by Gaetano. I was just looking for the exact quote so I could say, hey, physicists are calling it anti-gravity, not just Kelly over there, a crazy crackpot on YouTube. This is coming straight out of VR, and your equations are there for you people that live and die by that. Okay, you can live and die. Go look at that thumbnail. You'll see it right at the bottom where they call it the electrical component and the magnetic component of gravitons, or spin one like whatever it is there, which is what it is. Getting bumped around and banged around by the photons on both sides. What happens? The gravitons in the middle flatten out. They cancel out. They become far less effective, all the way to the point where they're useless. Do you understand the words that I am saying to you? Anyway, we get off that, but we were getting to our point. And for some reason, because of the Bob Lazar thing, movie coming out, and also Merrick von Rennenkamp and Zane and the Chawla have a new video out revisiting and summarizing the Gimbal, which we'll get to that. The Gimbal UFO. You know what that is, don't you, folks? Because you saw it in the musical interlude in the beginning. And, this thing just happens to look like Bob Lazar's saucer or whatever. So, in 2019, I almost said 19-something. 2019, I made this little drawing here. If you're on UFO Twitter /X, you've seen it 1,000 times. Not lately, because it's 6 years old now. So, if you look at this, you got to look at your screen. You'll see this central arrow here, where I'm showing light being pulled in and pushed out. And it was also kind of like the thing that Mark McCandless was talking about at the time. McCandlish, not McCandless. Was talking about it at the time. These things have a central tube in the middle. He said it was mercury or something. But I can see it. It's a thing that's passing light through it like that. And that close, those close, tight beams, that's what the metamaterials are for. Go back 2 videos. And you'll see that, see how easily you can manipulate that stuff. in theory. And it's not theory, it's just being done on a very small scale now. So it's not theory. It's got to be scaled, like all this stuff does. And that's another takeaway from here, where I will be browbeating and lecturing any naysayers or negative Nancy's that come along with this. Like, so what it's in there? It's a weak force. Yes, everything's weak until you scale it up. So my point is I brought this drawing back up to just show you how it could be, how what we're talking about with the repulsive gravity or quote-unquote anti-gravity can be used. Just stick it right in the middle of here. Look at the thing, see the arrow there, which it points in the direction of thrust because you're pulling in photons and you're pushing them out. And, you're picking up all that momentum and mass equivalence. That's the old lesson that I've been harping on. And I always suspected it's also going to affect gravity because it has to. Because of Eddington, because of Einstein, because of cause and effect, all that good stuff. And these guys have spelled it out in equations. So that improves upon our position here about all that stuff. So I have linked below a thread on X. I don't know, 10, posts hitting the highlights, the history of how this happened. And I don't think I don't think you want to hear me read it word for word, because an AI with a British accent could do that much better than me. And you can read it yourself at your leisure. But I am going to go over them, and I'm going to skim over them, and I'm going to read some words, and I'm going to summarize and do all that for the record. So I asked Rock, okay, you told me a bunch of stuff. Now summarize it in the order, a chronological order, because it starts spewing, scientists and papers at you, but they're out of order. So this tells you who built on what, how, and why, basically. Once upon a time, the story begins in the early days of General Relativity with Einstein's realization that gravity affects light. In 1911, blah, 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 blah. In 1919, I'll just read the bolded parts. There's a good idea. No wonder I did it. In 1919, Arthur Eddington led to the expeditions to observe the total solar eclipse in Brazil and Africa. Their measurements of starlight deflected by the sun matched Einstein's GR prediction, catapulting the theory to fame and proving that gravity bends light paths. Okay, so in my position ever since I learned that is, well, why can't that be? Why isn't that equivalent? Why isn't that symmetry? Why isn't that cause and effect? Why isn't that equal opposite reaction and all that stuff? It's just common reason, but it's not looked at too much, is it? Well, it is now. Like, share, subscribe. Fast forward to the 1930s. Physicists asked whether light beams themselves could interact gravitationally and with one another. In 1931, Richard Tolman, Paul Ehrenfest, Boris Podolsky published on the gravitational field produced by light. And then what happened? The counterintuitive result, a test photon traveling parallel to the source beam experiences net zero gravitational attraction while one traveling anti-parallel opposite direction is attracted. So if the beams are going together, you get this repulsive effect because they should be attracting each other. If they're coming the other way towards each other, they are attracted like normal real life. But in nature, this is just the way it is, folks. Don't blame me. They offered no deep physical explanation. John Wheeler, there's a name that everyone likes to parrot, and even he's in on this. revisited this in 1955, because I know none of you heard of Sparano, Vilasi, and Vilasi, which sounds to me like a personal injury firm from North Jersey, but never, anyway. Wheeler revisited this in 55, generalizing it to two interacting beams and adopting it as the foundation for his Geon model. Hypothetical self-gravitating bundles of electromagnetic radiation, that's light, held together by their own gravity. Ugh. Wow. I thought I was far out. The TEPW puzzle was born. So if Tolman, Ehrenfest, and Podolsky and Wheeler all get in on this, it's good enough to be called a puzzle and be born. And then what is it? The question was, why does gravity from light behave so asymmetrically depending on the direction, unlike ordinary massive particles? That's a good question. What does it mean? John Michel. Next. The next major step came in exact non-perturbative GR. In 1969, W.B. Bonner, which looks like Connor, only spelled with a B, found an exact solution. He showed that two such beams traveling parallel, same direction, do not interact at all. Their metrics superpose linearly, with no mutual deflection, exactly reproducing the TEPW no attraction result, but now non-perturbatively. Anti-parallel beams, however, do attract. All right, so he proved it. Bonner also proved a uniform light beam is gravitationally stable, and the parallel light pulses or beams shining in the same sense remain parallel indefinitely because gravity's canceled there. Special rule. Isn't that special? This confirmed the linearized puzzle was not an artifact, but a genuine feature of GR, Erics. Even in the full nonlinear theory for parallel propagation. All right, so another step. This one. Then what happened? In 1998-99-ish, Valerio Faraoni and R.M. Dumpsky, Dumpsky, not Dumpsky, revisited the problem using gravito-electromagnetic GEM formalism. Now we're getting into the math here, all right? So this is difficult to read, although you can see on the equation, which, believe me, if I can see it, it's not that hard. You need some engineering background or physics or something, or both, or a true love of math, or in there. So it's just saying the electric fields and a magnetic field, so and so, and this and that, of the light beam are canceled. The gravity is exactly canceled by the gravito-magnetic repulsion. So I think they brought in the repulsion word. So that's why we can forgive them for calling it repulsive gravity, which at first glance sounds like, wait a minute, you found pushing gravity or something like that? No, you just found plain old anti-gravity, but to do that, you had to go through this repulsion hoop. So, they also proved Wheeler's conjecture quantitatively. So, I'm not going to read what that is. Parallel PP wave, superimposed linearly, etc. Go look it up. Thread is linked right below for you. There's no excuse. All right, this is going to be on the test. J.W. Van Holten advanced the exact solution picture in 2008. Quote, the gravitational field of a light wave, unquote, and later works. He derived the full metric of curvature, etc., and so forth. In back to the bold, his results clarified the scattering of neutral particles by a light wave's gravitational field, all right, and extended the analysis to Klein-Gordon fields in the wave background, reinforcing that light carries its own pp wave gravitational dress. All right, that's physics jargon for light affects gravity. Okay, that's how we can dumb that down for me. I need a sip. Pardon me, or I'll burp. No one wants that. And then what happened after that? Well, time went on. 2 years later, the decisive modern resolution happened in 2010-2011. With Sparano, Vilasi, and Vilasi, I'm proud of myself for not saying soprano like I was in the rehearsals. The Gravity of Light is their paper, and that's linked below too. Building on TEPW, Wheeler, Bonner, Ferroni, Dumsey, and Van Holten, they move beyond linearized using exact nonlinear solution of Einstein's equations. That's when they go in there and tear that stuff apart. They take Einstein's equations and back them up. Because to get up to those E equals mc squared, that E on the other side has about 7,000 equations leading into that. Maybe not that many, but a lot. So they just back it down a couple levels, which should happen more often. Okay, back that up a bit. So, okay, I'll repeat it. Exact nonlinear solutions of Einstein's equations. They show that light can source nonlinear gravitational waves carrying physical spin one-like components. That's a fancy way of saying it can screw up gravity and make something else out of it. The spin one-like component is called a massless spin one graviphoton. And that's what's going on in between those light beams. When they scramble the gravitons and cancel them out, they make a thing that physicists like to call a massless spin one graviphoton. And as soon as your beams fall apart, that falls apart, and creates a wave, regular gravity wave. I had to ask that question this morning. Because I was thinking about it first thing in the morning. That's why I wake up dreaming about it. These components are not removable by gauge choice. In other words, they're there, and etc. In the same helicity, well, the math says so. The same helicity, parallel same polarization configurations, they produce a repulsive effect that exactly accounts for the lack of attraction seen by TEPW, W being Wheeler, you name droppers, and Bonner. Opposite helicity, the nonlinearity of GR is essential. Linearized theory misses these spin one channels. That means you had to back it up. Had to back down the equations. They speculated this repulsion, but you had to back down the whatchamacallit. Okay, let's keep going. Subsequent work, we're mostly done with this part. Subsequent work by the Vilasi group and others, bold, repulsive gravity with impure GR. Okay, now we're just reiterating a bit. Van Holten returned in 2022 with closed-form descriptions of light wave gravity fields. Okay, he improved it. Today, in 26, the state of play is settled theoretically, but observationally elusive. Well, let's do some more experiments, and we'll get to those later. The puzzle is resolved as a feature of GRs, nonlinearity. Parallel same direction light beams, repulsive canceled interaction because of exact cancellation. So we're repeating in more detail. Now, if you'll excuse me, I'm going to go turn up the AC for a minute. I'll be right back. All this yabbering's got me warmed up. Let me see. Subtleties. Ordinary. Okay, here's a good one. It has no practical impact on optics or astrophysics at ordinary scales. Yeah, that's because it's extraordinary. This doesn't occur in nature. You have to create order to do that, which human beings do. And I'll be preaching and harping on that in a minute. But it remains a beautiful illustration how GR's exact solution reveals subtleties hidden in approximations. Editor's note. This is me chiming in here on my own post. But that post quotes Grok. Words like tiny and weak. No, editor's note. Words like tiny and weak are why engineers exist. To create artificially high, extraordinary scales and make energy density happen. You got to make it happen. Nature is there for us to harness and tame, as was done via the tiny and weak photons driving this thing you see right here, which is a rocket emoji. Every one of these tiny and weak things you see or hear about is the same thing that adds up and builds up to move your car and to shoot your rockets and fly your planes and all that crap. So don't let Grok black pill you on that stuff. Bottom line summary. So I asked him, okay, summarize all those 6 things I just read, those post paragraphs. Summarize it. Okay. In short, Einstein and Eddington proved gravity bends light. Tolman, Ehrenfest, Podolsky, and Wheeler discovered the puzzling asymmetry for light beams in linearized GR. Bonner showed the same no attraction for parallel beams holds exactly. Faraoni, and Dumpsey, I'm saying it, explained it via perfect gravito-electric gravito-magnetic cancellation, which even I can understand that. And that's what the equations show. And even that equation is simple enough to me to recognize most of what it is. And all it says is E cancels B. Remember your right-hand rule? There's your 2 right hands, okay? 2 thumbs up, 2 fists, this and this. Please tell me. Let me expand the screen here. Please tell me you remember these right-hand rules. Okay, well, what we're going to do is back up and do this. 1 thumb up, 1 thumb down. Cancels it out. So if one viewer gives me a thumbs up, and another gives me a thumbs down, then what am I? Even Steven. All right. So that's what we're talking about with equations here. Where was I? Oh boy. Well, I remembered to do the thumbs up thing. Okay. Van Holten, we left off with Faraoni and Dumpsey. We're picking up with Van Holten, but only in one sentence. In 2008-ish, detailed the exact wave fields. Sparano, Vilasi, and Vilasi delivered the elegant, nonlinear resolution. Light sources, physical spin 1 gravitational waves that repel in the same helicity. meaning if they're going together, they cancel it out. Turning the old puzzle into a deep feature. I like the sound of that. It's a deep feature of Einstein's equations. So, Erics, you got to look for the deep feature. And a deep feature says anti-gravity. Anti-gravity. The entire chain shows how each generation refined the math. From weak field approximations to exact nonlinear solutions, revealing richer physics at every step. And I'm out here eyeballing it with intuition until I found this just a week or two ago. This extreme detail, which had to be there. All right, it was driving me insane. It's like, is this the hidden physics? Is this the secret illegal physics? Well, you know what? It might be. I mean, these are the guys that are allowed to stay out there. Foreigners, aren't they? I wonder. Anyway, I wonder if anybody picked up on that. You conspiracy theorists. And string theory theorists saying that's a fake, head fake or whatever, and secret physics. Go down this rabbit hole. Jump. Because there might be something to that. I mean, I'd do it. Say I'm General so-and-so, and I'm looking at this. The guy in the movie about the atomic bomb. Matt Damon played him. The Irish guy played Oppenheimer. Oppenheimer, of course. But the Damon character, General Case or Lane, some four-letter Anglo-Saxonish name, he was the one calling the shots on who's doing what. And you can see why they would just say, oh boy, we got anti-gravity here, folks. Wheeler picked it up in 1955. Is that what happened? I don't know. Jump down the rabbit hole. I'll buy it. I'll click on it. So, today, did I read this entire chain part? Yes. Today, the story is complete. GR handles light gravity consistently, with repulsion and attraction depending on the configuration. But the forces are so feeble, they remain a theoretical jewel rather than an observable phenomenon. In other words, they do see it, they think they see it around, galaxies and whatnot. I saw the word dark matter in here somewhere, someplace. But it's not a thing that you're going to, where do you see that? You're going to go to the planetarium and see that? No. So that's why we need an editor's note. Because 200 years ago, you didn't see rockets there either. You saw the moon or something, and a couple of stars. Editor's note. Listen up, you black pillars and deniers and doubters. Words like feeble fall into the same category as the previous note for weak and tiny about the rockets. Feeble in nature can turn into formidable when a little shaved ape ingenuity is applied. And the emoji on this one, you listeners and not viewers, is a little atom emoji and a little guy's head exploding with an atom bomb. Because what's one atom falling apart? A neutron and a couple of photons get loose, a gamma or something, okay? I wouldn't want to be in the same room with it, but it's not going to explode anything. It's not going to power giant cities with power. You got to scale that feeble up, my friends. And I'm here to do it. Is that convincing? All right, so we're mostly done with that thread. Summarized in 2 sentences by me in the next post. In other words, I didn't even type that out. I'm too lazy. IOW, gravity affects light, and light affects gravity. The latter part of that being where the solution lies. That's where the solution lies, until it's disproven. Don't give me feeble, don't give me tiny, don't give me no one else ever did it before, don't give me I never heard of this. You're hearing of it now. He just didn't look down the wrong path, right path, or this path, right, wrong path, whatever. In everyday words, one more summary. I think I asked for a summary of the summary. In everyday words, parallel same direction light beams have zero net gravitational interaction because, bullet point, in the easy approximation, the pulling gravity and the moving related gravity cancel each other out perfectly. Bullet point 2, in the full exact gravity, there's an extra tiny repulsion from spin 1-like gravitational waves that lights create. This repulsion makes sure any remaining attraction gets wiped out when the beams move together in the same twist. In other words, they word it in a hard way. Spin 1-like gravitational waves that light creates. That means the gravitons are scrambled, cockamamie, and confounded and discombobulated. That's what that means to you and me. And anti-gravity's muted, shut off, turned down, unplugged. And what you want to do, again, you want to have that on your spaceship. Okay? So, when the aliens get here, don't be surprised if a big chunk of them aren't doing this. And you don't, the closer, and that's going to work anywhere. The closer you get that photon to photon, you don't necessarily need those straight beams. You get that light closer and closer and closer in your bismuth or whatever it is, your mechanical waveguide, your plasmonics boofing waveguides. When that light comes out, when that light's guided, whenever it's emitted, whatever you want to call it, when it's going through, you want that stuff moving and squoze together, going straight down that path. Because when you're doing that, you're canceling out gravity. In addition, but wait, there's more. In addition to capturing and exploding all that momentum, which is what a rocket does, only it does it slower because it's stored in the gases, or it's stored somewhere. They have solid ones too. But the driving thing, yeah, I know they dump mass, I know that, but if you don't, that's we're not going to get into that now. That's a good argument, black pillars, but it only goes so far, because in the end, it's a rounding error. You just haven't captured enough light yet to do it, to know that. So, summarizing, it's not that gravity stops working. This isn't woo here, folks. We're not making stuff up here. We're not making up. It's that parallel photons going the same way, all the pieces add up to exactly nothing. 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 One thumb up, one thumb down. Nothing. Your net is nothing. When they're going toward each other, the pieces add up to real, though still tiny, pull. But it's there. Well, you got to scale it. They love trying to. Well, it's true. But you're dealing with tiny particles. So it's tiny. It's tiny to us. It's not tiny to them. If I'm a light beam and I'm getting pulled off my path, I want to know why. It's not tiny. This story, from the 30s puzzles to the 2011 by Sparano, Vilasi, shows how going from approximate math, which is what all of these people are doing right now, that all over your alt propulsions and your UFO Twitters and everywhere else, all the way to the Erics themselves who work in this stuff, they're still using the approximate math, which makes sense. If it works, it works. But you forget about the other stuff that brought you there. And there's an old saying about dancing the one that brought you there. But Doesn't really apply, but I just thought I'd say that. But don't ignore it. So my advice, look at your screen if you got one, to you folks, is to follow Bluto. And let's do it. Don't fall for the tiny, don't fall for the feeble, all that, Don't sucker yourself into saying, I would have known that, because you didn't. Because if you did, I would have learned it from you. So, let's go that way. Here's a picture. I know some of you are listening. That's what I do, walk around listening. Here's a picture of a young Steve Jobs. Now, does he want to be told that a giant mainframe computer will never fit into a phone or something, or a desktop or whatever? No, because he can see it scaling all the way back when he had this haircut in high school, okay? So think that way. So that's your parallel. These are our role models here who have done this stuff. Instead of miniaturizing energy, which is what we're going to do, which is not what I'm obsessed with, being fully retired, and we'll go to my grave doing that. He did it with data. Huh? It's the same particles, it's just a different use of them. And I just got a new phone. I don't use iPhones, but it's amazing how much they keep squeezing into that. And here he is introducing the iPhone. Rest in peace, sir. Here's another picture in the middle here of him with his hello PC, wearing a pinstripe suit. I think I had that tie back then. Let's see his business card. Does it have a raised watermark? All right, and there's the original iPhone. Look how cute it is. Aw. So don't think of Bluto. Think of Jobs. In all three pictures, think of Elon Musk here. Look at him. Is he going to let the world know? Now look at this electric car and compare that to the first ones and the old ones. I mean, I remember the Chevy Bolt. Yeah, Bolt. In the 90s, you'd see them running around. And we all seen the 1902 Electromobile and things like that. That's how energy density works. Now, I guess he's probably getting more and more energy density out of the rockets. I don't follow that. I know he must be. You can scale it up, but you also got to scale it down. So I'm sure that point isn't lost on him. And what do you get with that? You get a car floating in space. I can't believe he dropped a car out there. An efficient, energy-dense car based on looking ahead and seeing what is possible. And that's what we got to do here, starting here at this stupid YouTube video, and keep going. So, looking at Bluto again, saying, let's do it. And we ease out of this segment by looking at the thumbnail again, because that's our little chapter marker now. And we see on there the two Erics, we see me, and we see Eddington and Einstein facing both ways. See, on this side, Eddington's the electrical, and Einstein's the magnetic. But on this side, the thumbs down side, it's the other way around. There, even Steven, it cancels out. Good job, man. Anyway. Yeah, and the name of this is repulsive gravity. Because people are going to hear that and wonder what, think it is what it sounds, like I did at first. I thought that residue, that spin 1 graviphoton, might be something like repulsive gravity, like a graviton spinning backwards and stuck there, so, something like that, turns it inside out. But it doesn't. It just flattens it temporarily and makes it useless. As soon as it's kicked out of the chamber, or the metamaterial or the waveguide. It's just another anonymous gravity wave in the scheme of things. Doesn't look any different, supposedly. I don't know why it would. And neither does Grok. So, through this chapter, I guess we're in the sort of miscellaneous part already. Yeah, just a couple of miscellaneous things. Link below, go look at it, is the new I may as well listen to it. Well, I don't have this lined up. It's the new Merrick Von R video about the gimbal, and it's pretty darn conclusive. A mere 23 minutes, he nails it, along with the other guys, the Chawla and Zane. So, and yeah, looking at this thing, yeah, we got to shout out to the people that leaked this. The Chris Mellons, the Elizondos. I guess Ryan Graves had something to do with this thing we're looking at here, with the whole fleet of them. And you got to look at that yourself. This is just a side thing. But when I look at this gimbal, I just keep seeing that central tube. And, that's one way of doing it. Take the express train, run a central tube right through you. Now that central tube, which kind of looks like it's on the gimbal too, and the Lazar thing and the McCandlish thing, and some other stories people have told, it's just an easier way to visualize sitting on top of that tube with a bunch of beams going through it underneath your feet. And within that, not only is gravity being kind of diminished because it's all light in there, it's a vacuum chamber, it's completely flattened. So what's a super balloon feel like? I don't know. If you could do that on a balloon-sized thing and set it here on this table, I bet it would shoot a hole straight through the frickin' moon. Pardon me. Pardon my language. So, that's just a couple of things. This is just a random web page I ran across doing this. It's linked below. I never mention it. It's from my website. If you're curious about how I got here or who this guy is, look at that. Look at that and look at the other link down there that says summary or something like that. It's on my website. I won't bore you too much with what I used to call my manifesto, which is what it is. And it's not bad. It's from 2019 also. So that's why I ran across it with that old drawing, which is this. And here it is again. Oh yeah, I was supposed to just go over that quickly. This old drawing here. It has that center part that we've been talking about, but it also has a couple of other. It's a sketch with numbered little arrows pointing at stuff. I'm just going to read it for a review and see what I was thinking back then. It's roughly the same, more refined now. Step 1. Ambient cold light is absorbed. Could be in the skin, could be in that central tube. We'll get to that. It's sucked out of the air or space itself. Well, it's going through space. It's nothing but cold photons. Nothing but light. Sitting there, waiting to be grabbed, pulled in, jammed together in a beam to create anti-gravity. That's what they call it. You can call it repulsive gravity too, which is the same thing. Point 2 on here. Antennae on belly and highly absorbent, yet photoluminescent skin to absorb and emit light. Okay? For example, Vantablack for in, graphane for out. Purported reactor consolidates and pumps most of it. All right, that's what we were talking about. Reactor, that's in quotes, belly's in quotes, because Lazar was on a big run back then, just like he is now. And it makes sense, engineering-wise. 3, light wave light wave guided through and around skin with metagraphene, vantablack, magnesium bismuth zinc, element 115, in quotes, or whatever pumps it best. So those are just examples of things you can use. And of course the magnesium bismuth zinc, I'll take another look at zinc one of these days, because we just did bismuth and magnesium oxide. And what's that? 70 to 90% of every photon in the universe can be pulled through by those two things with little fanfare. And we're going to squeeze that, pull it through, absorb and emit, wave guide it through, squeeze that in there, so we're going to get our repulsive gravity effect as between the beams and photons, which will create the quote-unquote anti-gravity effect. Straight out of GR, folks. Not just me anymore. Step 4, light, mass equivalence, another Einstein thing. Emitted through the skin in purported emitters, okay? So you're also throwing its mass equivalence. They don't call it mass because it isn't, but that's only in definition. That's a naming convention, which there's a lot of problems with that in physics and science and everything else. Somebody said, okay, we'll draw the mass line right here. But this is mass equivalence. It's not mass. Don't call it mass. Just call it equivalent mass. Mass equivalent. All right. So teeny and tiny, I can find a teeny and tiny piece of mass too. And then make Mount Everest out of it and drop it in your backyard. How do you like that? 5. Craft's mass is offset by overwhelming loss of mass equivalence. In other words, you're blowing out a lot of mass equivalence. And let me make this point for you rocket fans. When you blow that stuff up once with all that mass, you blew it up once. You got to go home and reload. This is pulling the fuel right out of space. It's blowing it up as long till the end of the universe. Heat death. Because light, it's there to do it. That's what it's there for. Do it. So you don't have those issues. So it compounds and compounds and compounds. When you take, what's it take? Thousandths of a second, I'll just guess. I think that's right. I can't remember. For chemical propulsion, okay, it's either 10 to the minus 3 or 10 to the minus 6. I'll even give you 9, because light starts at 15 and can go to 18. And it does that every second. Your thing blows it up quickly once. Mine does it quicker every, billions and trillions of times faster. And it keeps going. So keep that in mind when you see these tiny and feeble and all that. You got to take that time and space and optimize it. And the time part isn't being done like it could. Time is another tool, to quote myself. Time is a tool when it comes to this stuff. You want to take those numbers and use them. And that compounds like compound interest and all that. It just keeps going. Merciless. So, point 6. Light could be pumped around or right back out as needed, cell by cell. So we're looking ahead. We're dreaming about this. These metamaterials, like even back then, 6 years ago, vantablack existed, graphene existed, bismuth existed, all that stuff. But even in that 6 years, if you look at and you should follow me on X to do this, because I do it every day, that the news comes out. The developments on nanophotonics and metamaterials and metasurfaces and all that, they just keep coming, man. And they come quicker and faster and more interesting and useful. Pardon me, I'm going to wipe my face before I slobber from talking so much. What was I yelling about? Oh, how fast it's changing, even from then to then. But you could start with graphene and use graphene, because those move light easily. They're simple to understand, relatively simple to build compared to some of these other things right now. So we're done with that little part there, because we've come up to our thumbnail again. What's next? Oh, yeah. So we're not just talking about theory here, folks. You're looking at my friend Wayne, whose video is linked below, Fail Forward Research. And this is a good one, where he's just using, light bulbs from, let's move a little bit. See that? Anyway, go look at it, because he's doing it in real time. He's doing experiments that show some of this stuff. And if you go back to my video that looks like this, see that? That's linked below. Wayne Ojala, I don't know, it's Spanish. Is the Z or is the J? Is it Ojala? But he tolerates us when we say it wrong. I don't know right now. Wayne. And let's look down here. That's the wrong one. These are on Rumble and YouTube. Somehow, where's my description here? It should. Well, it links these other people that are seeing other scientists. Go find that, and you'll find the papers linked to scientists mentioned. But it's not as mathematically rigorous as what we just discussed here with Vilasi. These are experiments done in labs, and these people are saying, hey, I'm finding these effects. What do they mean? Where are they coming from? And we're seeing it in the real world here. You can see Wayne's pendulum swinging back and forth from the light, being on and off. He's done everything he could to rule out air interference, heat, and all that stuff. Go listen to it. No, it's not perfect, but it's demonstrating something that can't be explained. And so there it is. So, oh, yeah, and it came out of, again, I'm going back to these original scientists here, and their observations and approximations. And I don't know how much experiment is involved here by Tolman, Ehrenfest, Podolsky, and Wheeler. This language in this thing could be read two different ways. The counterintuitive result: a test photon traveling parallel to the source beam experiences net zero gravitational attraction. Okay, they call it a test photon. When I read that at first, I'm like, oh, they tested it. I don't know that means that. They're just saying this is what it will do. So, I'm saying over here we're seeing mysteries here with Wayne and other people. And if you go to APEC, there are other people doing things with light to an extent. Frankly, I think a lot of them are doing it without knowing it. I'm not going to name names, but you can go right through that thing, and you'll see a lot of that. I just named electrostatic and Biefeld-Brown 2 days ago, so I'll name it again. That stuff's interacting with photons, I think. Until that's ruled out, I don't think you want to rule in claims you shouldn't really rule in yet. I could be wrong. Anyway, go watch Wayne. Let's leave him off so nothing goes wrong here. So my point is, watch Wayne, go back and look at this other video of mine, and you'll see it in the real world. And if you're looking at flying saucers with photonic signatures that you can't explain, that act like they're moving in anti-gravity, and you have this thing right in General Relativity that says you can get anti-gravity from General Relativity, why would you not focus on that? That's my question to you, to everyone. Now we're looking at and we're getting into the part where this general principle is out there. Here's something tiny. I call it a water molecule. It's tiny. It's feeble. Well, what if I pump it like we're going to pump light? And when we pump it, it's going to do that. They're going to squeeze in there, and we're going to get that repulsive gravity effect. And we're going to get that anti-gravity effect from a minuscule, feeble thing. Like this gigantic Virginia-class submarine pumps water. This is the state of the art, the pump. You pull through, you're going through a thing, a medium, and you pull it through yourself, is what it's doing. And we're going to do that in space. And they're not going to put nuclear reactors and all this. This is the state of the art, these things. Deadly quiet, dominating the seas and coastlines. You want to dominate space and your atmosphere? I think you better look hard at pumping light. Now look at that picture of a light pump. That looks like it could go somewhere, doesn't it? Oh, it's not a light pump, it's a water. It's a pump jet. It's called pump jet propulsion in the world of submarines. And that's your jet skis and other things in the world. A squid does that. It's not a big mystery where you need forces from the 18th dimension and element 2015 and space ghosts and anything. Just do what's in front of you. Look at the easy way first. All right. Enough of that. And here's I don't know why this came up, but as you might know, I am suspicious of butterflies. I don't trust them. I think they're doing this right under our noses and laughing at you. Look at that butterfly wing. Go look at the screen. We got morpho butterflies, those bright blue ones, and we're looking at their scales and our waveguides in there. Those are called structural colors, generally. And that's like saying, I got a waveguide built in here that makes stuff red on my wing, or blue, mostly blue. And the reason I don't trust these butterflies is they flit around a little bit too much for Newtonian, rules to be followed. They're pushing air, but how can they really push that much air? I mean, how can you trust these things? I think they're doing exactly what now I'm mixing up Lucchese, Sparano. I just looked at it. Gaetano, let's call him that. I can remember that. Gaetano and Eddington and Einstein and the other guys on there, and maybe one's a gal. I don't know. The second, Vilasi, that's it. See, I remembered without looking it up. Anyway, I don't trust butterflies, and that's why. They flit around too much. They drop like a rock when they want to. Same with some other bugs. So, I'm saying the shaved ape has already understood what a pump is, generally, and how pumping little things can add up. This animal, and other ones, I think, have, and this happens in bird feathers too, by the way, and I think in some sea life under there, you see them glowing and moving up and down. I don't know what's going on there. But these butterflies are just right in your face, landing on your nose, laughing at you, because you didn't know what anti-gravity was. So we'll just leave it right there. And now we're coming to the end here already, huh? And I'm saying, look to the butterfly, the squid. Look to the equations. They're right there for you. Done already. And use your imagination a little bit. And scaling and thoughts like that. I hope you got the point. But for some reason, all that added up a few hours ago to me to look to the cookie from Seinfeld, which if you look at your screen, that's what they're doing there. The black and white cookie. Okay, and that's also the black and the white represent the Eddington and the Einstein and the electrical and the magnetic and the two photons canceling like the black and white cookie does. What is it in the end? Is it chocolate or is it vanilla? It's a mixture. It's mixture. Neither. So it's canceled. So maybe that's... But there was something I thought was the cookie. Oh, the cookie is repulsive gravity. Of course, it's the name of the thing, isn't it? The name of the video. The big letters, the bold letters, the 72 font. Repulsive gravity. Now, that's what they call it. So I'm calling it that now, just so it gets out there and it's understood that it's not exactly what it sounds like. It's just plain old anti-gravity. Proven in GR. That's all. Just got a funny name, but we're going to respect that name. Because the people that came up with it that way. And they said, not only is it repulsive between the photons, which is what they were looking at. That's the problem they were solving. Why is it acting this way? Well, it's repelling. Shouldn't they bang into each other and going into infinity? No, they're repelling. And that just happens to be what we call anti-gravity. All right? So that's your cookie. Look to it. There's another picture of Eddington and Einstein on the park bench. Looks like Einstein's laughing at a dry humor comment Eddington made with his British humor, I guess. He looks like he wants to laugh at him. And Eddington looks like he's either dead serious or he's trying to fake it. And Einstein's maybe kind of falling asleep, not laughing. I don't know. Look to the cookie again. And, here's a picture in the end here. Here's our guy, Gaetano. He should have been in the intro pictures with the music. But there he is right there. Now look at him. Thank you, Gaetano. If we can't look to the cookie, where can we look? Maybe it's not that funny. But we can look to Gaetano. And I urge you to do so, because it's in there, Erics. It's in there. It's called repulsive gravity from light and general relativity. And look right on the thing. There's your equation. I can read half of that. All that shows is electrical and magnetic field, E and B. And those little squiggles in there represent the pieces of it. And there's a constant in there I don't recognize right now. But you can look it up easily. And then you got your 1/2 and you got your -2, which, good combination. Because it adds up and cancels out. as per Sparano, Vilasi, and Vilasi. It's in there, Erics. It's in there. There's Gaetano looking at you, smiling at you, saying, someday these people are going to know that it was in there. All right, folks, I'm done. I'm going to try to do an outro without ruining, last time I cut it off. I stopped when I should have paused. So now I'm going to pause and try to do an outro. Why? To irritate you? No. It cheers me up. But you can sign off now unless you want to hear, I think it's called, that song called Alpha something.